The question we are solving now belongs to test series 6. It is of signals on system subject. In specific, it belongs to frequency domain analysis of LTI systems. As per the question, it is given that there is a linear phase system and it has real impulse response. Now we need to find the correct transfer function which represents this linear phase system out of the given options. That is, out of the given options, we need to pick the option which corresponds to the linear phase system with real impulse response. Option A says 1 minus 2 e power j pi by 6 z inverse multiplied by 1 minus half e power minus j pi by 6 z inverse. Option B says 1 minus 2 z inverse multiplied by 1 minus half z inverse. Option C says 1 minus 3 into e power j pi by 3 z inverse multiplied by 1 minus 1 by 3 e power j pi by 3 z inverse. Option D says 1 minus 4 into e power j pi by 4 z inverse multiplied by 1 minus 4 into e power minus j pi by 4 z inverse. So out of the four system functions given, we need to find out which of them corresponds to the linear phase system with real impulse response. We know that if a system is a linear phase system, its zeros form conjugate reciprocal pairs. It means that if there is a 0 at z, then there should be another 0 at 1 by z star. And also it is given that the system has real impulse response. It means that the zeros of the system in this particular case should be real. In case the zeros are complex, they should be complex conjugates. That is, given any generic system, if zeros are real and are complex conjugates and vice versa with the poles also, then the system will have the real impulse response. So from this we see that out of given four options, which of them has zeros as conjugate reciprocal pairs and zeros as either real or complex conjugates. The option which satisfies these conditions is the one that we want. If we pick the option A, the zeros are located at 2 into e power j pi by 6 and half into e power minus j pi by 6. Let us assume that z is equal to 2 into e power j pi by 6, then 1 by z star can be written as 1 by 2 into e power minus j pi by 6, which upon simplification becomes half e power j pi by 6. Here we see that zeros are not conjugate reciprocal pairs, so option A is not correct. Similarly, now if we pick option B, the zeros are located at 2 and 1 by 2. So if I assume that z is equal to 2, 1 by z star is equal to half. It means that zeros form conjugate reciprocal pairs, so the system is linear phase. Also we see that the zeros are real, because of which we can say that the system will have real impulse response. So the system in option B is a correct option, is a correct one. Now let us consider option C. Now here we see that the zeros are not complex conjugates, hence the system will not have real impulse response. So option C is also not correct. Similarly, if we consider option D, in this case also we see that the zeros are conjugates, so the impulse response will be real. But if we see that if there is a 0 located at 4 into e power j pi by 4, we expect another 0 to be 1 at 1 by z star, which boils down to 1 by 4 e power j pi by 4. But there is no 0 located at 1 by 4 e power j pi by 4. Hence we can say that the system is not linear phase. Hence this is also not correct option. From this we see that out of the four options given, the option B corresponds to the system which is linear phase and having real impulse response. From this we see that the correct option representing the given requirements is B.